ओके सो बेटा देखो, आज जो हम आपको पढ़ाने वाले हैं उसकी ये आउटलाइन है. This is the rough outline of what we'll be discussing today. First of
Yes.
all, why mathematics is required in physics. All right. So if you have a very clear perspective of every chapter that how things are working, right, then you will be able to appreciate mathematics in physics. And I
Yeah.
must say that without mathematics, physics is not complete at all. All right. So we need to understand that at what part mathematics get involved in physics. All right. So first, let us
Okay.
have a look at that. So you can see this picture. I think you are quite aware of this picture and the scientist, right? Isaac Newton, right? So he
Yeah.
must be a great man because he could think of by seeing apple falling on the ground. He could think of something that some great questions like why did the apple fall, at what speed, what the time it took. Like so, this part is basically called the observation part. All right, this is an
Yeah.
observation. You make an observation. Once you make an observation, then there are many questions that are arising in your head that needs to
Yeah.
be answered, like for how much time it took. If I throw it from the double of the height, it fell, then how much time will it take? What is the relation between that height and time? All right. With what speed it is falling? Will the speed change if I give it some initial velocity? So these are all the questions that needs to be answered and that are answered inside a lab. Laboratory,
Yeah.
where there are several apparatuses, and with the help of those, we can conduct some experiments. All right.
Yeah.
So till now, mathematics has not come into role. The first step is observation. The second step is experimentation, where you do a lot of data collection. All right.
Yeah.
Now, in order to make sense out of this data, you have to fit this data on a mathematical equation. All right.
Yeah.
Because every another guy or a layman to whom you will propose your theory, he will not go to the laboratory to do an experiment, right? So
Yeah.
he should have some basis on in his hands to conclude what you are saying. All right. So, for example, you might be closely watching the news of Russia-Ukraine war is going on, right? So
Yes.
those guys are using missiles, right? And I
Yeah.
will be teaching you the motion of the missile as a projectile motion when we'll be studying 2D motion. All right. Now, what if they don't know where this missile will land? It can't be the case, right? They are sitting in
It
Russia.
can be calculated with the motion, like its speed. It's like it's not like the missile can fire go to the air like forever. So
Yeah,
there is a time comes to an end due to the force of the air or wind. So
yeah,
like it's like the backwards motion or the friction in the air. Yeah.
exactly. My point is, but the point is, they already had those calculations in their softwares, isn't it? Before
Yeah,
firing that,
that's why they have
yeah,
guided missiles. So like, they
that's
know
why
where they
that's
will
why
land.
they can target really well, isn't it?
Yeah.
So the point is, those calculations arise out of some mathematical calculations that were already done based on the experimental data. That is the point I want to make over here, isn't it?
Yeah.
So once the data is collected from the laboratory, we fit that data into a mathematical equation. All right, that's where the
Yeah.
mathematics comes in. Now I think I can see you really clearly. You are really, it was very black out there initially.
Yeah. I think it was some setting that activated. Yeah. I think
यार
it
ये
was my
तुम
finger.
पहले करके रखा करो बेटा सेटिंग को. अभी तुम्हारा वॉइस भी थोड़ा स्लो लग रहा है मेरे को. I think I'll
Can,
appreciate a little louder voice and a clear voice.
yeah.
Yeah, so it will increase our efficiency.
Yes.
All right. So now I think you can appreciate the role of mathematics. The mathematics comes in after the data collection and the analysis part. All right. So how the velocity is dependent on the height from which the ball is
Yeah.
being thrown. You have to have an equation for that. All right. So
Yeah.
when I will be teaching you motion, I will be teaching you equation of motions, that how the velocity depends on time, how the velocity depends on height, right? What other parameters are there? Are we considering
Yeah.
air friction? what will happen if we consider air friction? All those things we'll talk about. Is it fine?
Yes, I understood.
Fine. All right. So now I am coming to straight away right angle triangle. So my first question is really answered, that why mathematics is required in physics. Now let me start with the very basic thing, which is new to you. So be very aware while understanding this, and we'll be practicing a lot of questions on this also. Now, Rajik, one thing is there, a right angle triangle is a very special triangle. All right.
Yes.
There are two reasons to it. One is we can apply Pythagorean theorem, isn't it? And the second is, one angle is for sure 90 degrees, right? So the sum of the other two will be short 90 degrees, isn't it? So in a right triangle, if we get to know even one angle apart from 90-degree angle, the other is almost also known, right? So right triangle is a very special triangle. Now the point is that I want to make, why trigonometry came into existence. Trigonometry is all about the ratio of the sizes, isn't it? It's all about the ratio of the sizes. So I'll give you a very brief example here, and you will appreciate the role of trigonometry by that. All right. So let me give you that example. Just a minute. So suppose I have got a triangle over here. Let's say I have got a right triangle over here, and it is like this. All right. And this angle is 90 degree and this angle is 30 degrees. All right. This is a very small triangle. Now, what I did, and let's say this side be P, this side be B, and this side be H. So I think you can make out.
See, the P angle would be 90 degree. So that's total of 120, but the triangle is 180 degrees. So 180 minus 120 is 60. So the other angle would be 60 degrees.
Yeah. But that is not the point I'm making right now. Listen to me. This triangle has got three sides. I named dot sides, P, B, and H, right?
Yeah.
Now, what I am doing is, I am doing this. I am doing this. I am like simply zooming in.
Yeah.
So my point is, if I have got a smaller triangle, all right, with one angle 30 degree, and if I've got a bigger triangle with one angle 30 degree, other than angle 90 degree, there is something in common between both of them. That is what I want to make. For example, if I make a adjacent triangle like this, and let's say I make an adjacent triangle like this. Just a minute.
Yeah.
Uh,
So the thing you are trying to say is like the size of the triangle does not matter. The angle is technically not dependent on the size.
no, no, there is one more point I want to make. The point I want to make is the angles are similar. And what is the similarity between the two is the ratio in which the sizes grow will also be the same. That is the point I want to make. So basically, let's say this becomes P dash and this becomes B dash and this becomes H dash. All right. But whatever P by B ratio is here is comparable to P dash by B dash.
Yes.
So get the thing right in your head. That is why I am talking about trigonometry. Trigonometry is all about ratios. Okay, so I have something in common with this smaller triangle and this bigger triangle. That is the ratio of the sides. All right. You have joined in from mobile also. Isn't it?
Yeah, sir, I've joined from laptop.
You can disconnect your audio then from one of the devices. Otherwise, it will cause echo. You can simply disconnect audio by going at the bottom. There is an option.
Yeah, sir, now it won't go.
And please make these settings before the class from the next time. Is it okay?
Yeah.
Yeah, fine. So now I'm talking about the ratios, right? So trigonometry is all about, I can find something in common between these triangles. And today I will be telling you, what do we call these ratios? We are giving them certain names. All right.
Yes.
The reason I have written P over here is because I'm considering this as perpendicular.
Yeah.
All right.
Okay.
And I'm considering this as base, and this
Yes.
is being considered as hypotenuse.
Hypotenuse, yes.
Yeah.
The longest side of the tile.
Longest side. So please bear with my handwriting. It's very dirty, right? But I think
Not
you will be
bad.
adjusted with it
Yeah. It's
over a
not
period
that
of
bad.
time.
Yes.
No problem. Now see this. I want to name certain ratios.
Okay.
So I want to make you learn these three ratios. First of all, sine, cos, and tan.
I think I already am familiar with sine because
It's
the
really good if you are familiar. Just let me
sine
complete
is
first. Yeah.
mostly denoted for the angle which hasn't been given any value, I think.
Which?
So like if I have to find a value for an angle, we just name it as sine r or something.
No. Listen to me. Sine of some angle, like I say sine of 30 degrees,
Yeah.
referring to this above triangle.
So
Means,
it's 60.
sorry,
So 90 minus 60, right?
that is all right. That is all right. Abhi pehle ek baar sun lo. We will discuss your opinion afterwards, right?
Yeah.
Just let me convey once. So sine 30 in this particular triangle is certainly defined as the ratio of perpendicular by hypotenuse.
Yes.
This is P by H.
Yeah.
Cos 30 in this particular triangle will be defined as the ratio of base by hypotenuse. And tan 30 will be defined as perpendicular by base.
Yes.
All right. So these are the basic definitions of the ratios. If anyone says to you sine theta, so something that comes to your mind is he's talking about a right triangle and he's talking about the ratio of perpendicular by hypotenuse.
Oh, okay.
Is it very clear now?
So in sine, it's the division of the other two angles, and in cos, it's the division of the angle and by the angle beside it.
So no, it's like sine 30. If we say, for example, if I got this angle as theta, let's say this is a right triangle, fine.
Yeah.
Now let's say this angle is theta.
Yeah.
Now somebody asks you, this is A, this is B, and this is C.
Yeah.
Now somebody asks you, what is sine theta in this triangle? So it's a
So
representation.
Yeah.
All right. So what will be the value of sine theta?
A upon yeah, it is A upon C, I think.
Exactly. You are perfectly all right. But I want you to let me know that how you recognize that A is the perpendicular and B is the base. B can also be the perpendicular.
Yeah, it's true, but sine is right there. Sine is always in the bottom. Yeah.
Okay. So now here goes the basic logic. The side in front of the angle is the perpendicular side.
Yeah.
All right. So when you choose some angle, all right, the side which is in front of it is the perpendicular and the one that is adjacent to it is treated as the base.
Yeah.
So I am writing it over here. So the side adjacent to the angle
Yes.
is treated as base.
Yeah.
And the side in front of angle
Yeah.
is treated as perpendicular.
Perpendicular.
Is it fine?
Yeah.
All right. So you are quite okay with this. You
Yeah.
told me that sine theta will be equal to A by B. A by C,
Yes.
sorry. A by C. All right.
Yeah.
Now, Rajik, tell me this. What will be
Yeah.
tan theta be like in this triangle? Yeah.
Tan theta. Okay.
It was the hint is written over the top, right?
Yeah. So in here, it is C upon B.
What is tan theta? Perpendicular by base, isn't it?
Yeah.
C is never the C is the hypotenuse, yeah.
Oh, okay. It's A upon B then.
Yeah, right. So ऐसा क्या हुआ? अभी तुम्हारा ध्यान कहाँ चला गया था बीच में? Where was your concentration?
Sir, I thought you were talking about cos. My bad.
ना ऐसे नहीं. ठीक है? Back to the subject. Now tell me cos theta.
Cause it would be this B upon C.
Perfectly all right. Now, Rajik, there is a one small question I am giving you to solve. All right.
Yeah.
In this triangle, concerning this triangle, can you tell me sine square theta plus cos square theta will yield me a value, an integer value. All right. Don't be in a hurry. Solve it and think it and then give me the answer. What should be that value be?
Sine square theta. So I have to square it actually.
You have to square, add, and then analyze, and then let me know.
Okay.
Yeah.
So subscribe. Okay. Sine is A upon C and cos will be A square upon C. Okay. A square plus B square upon C square.
What I said initially, I want you to analyze it further and give me a numerical integer answer at
Oh,
the end.
okay.
Yeah. Use your pen and paper. Yeah.
Yeah. So here, in this case, sine square theta square theta plus cos square theta equals to question. So your sine equals to A upon C. So cos equals to cos is B upon C. So sine square theta would be A square upon C square theta.
No, theta nahi aayega. Sine theta itself is A by C.
Yeah,
All right.
A square plus C square and cos would be B square upon C square.
Right.
So I have to
Now
add
I
them.
want you to analyze this.
B
You
square.
take the denominator common, right?
Yeah.
So what will become at the top? A square
A
plus B
square
square.
plus B square upon C square.
Still, you can reduce it further. You know it.
Yeah,
A
okay.
square plus B square is what?
Oh yeah, okay, got it. A square plus B square is technically A plus B the whole square minus 2AB.
उतना कॉम्प्लेक्स मत करे यार, ये चेस का गेम नहीं है, ठीक है? डोंट मेक इट कॉम्प्लेक्स. पाइथागोरियन थ्योरम लगाओ यार.
अच्छा, A square plus B square is C square. So
Exactly.
it's 1.
Exactly. Got it, no? So by applying the Pythagorean theorem, you got A square plus B square as C square upon C square, and you got the answer as 1.
1.
So I want you
So
to
you are
remember,
trying to say when you square sine and cos and add them, the answer will always be 1.
and it will be very, very helpful for you. This particular, it is called an identity. All right. We call it as an identity property. All right. So this particular value will always yield you 1 no matter what kind of triangle it is.
Yeah.
So it's a very important point to make. Once I am done with the lecture, you can just note down the important points in your classwork copy. All right. Rather than spending time right now to write them. Okay. So that we can cover a lot of things today, right?
Yeah.
So you will spend like 40 minutes to get all these notes, only the important points in the classwork copy, and this PDF I will be sending to you. Okay.
Yeah.
Yeah. So sine square theta plus cos square theta is 1. Is it fine in your head now?
Yeah.
Now, I am asking you another very interesting thing now. Tell me, what can be the maximum possible value of sine theta that sine theta can attain?
Sine theta.
Yeah.
Okay.
The maximum possible value sine theta can attain. Can you feel that?
Okay, so obviously A would always be 90. So the smallest would be the smallest value or the greatest value?
Greatest.
Greatest would be always 90, maybe. 90.
Okay, don't get confused. Theta is one another thing, and sine theta is the ratio. All right.
Yeah.
So
Oh,
if I
wait,
want to maximize sine theta,
Yeah.
okay, think like that. Then it is P by H. All right.
Yeah.
If I go on increasing P,
Yeah.
right? If I go on increasing P, sine theta will increase, isn't it?
Yeah. Yeah.
And in fact, this angle will also increase
Yeah.
because this angle is theta angle. This side is P. All right. So as you go on increasing theta, 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 theta like this, you can go to a max of 90 degrees over here, isn't it?
Yeah.
Already you have one angle is 90 degree. And if you will go on increasing this, what extent you can go? Maximum 90. That's all, isn't it? And at that time, what will happen? The perpendicular value will be quite similar to that of the hypotenuse.
So
That
theta's largest value will be 89.
side,
No.
right?
No, wait,
Sorry,
it can't be because like the
it's
sum
an
of two sides is always greater than the third
it's an
one.
imaginary case. It's an imaginary borderline case. All
Yeah.
right, where you are where you are no more left with the triangle. All right. So it's an imaginary borderline case that I am trying to push to. All right. So if you go on increasing such that the perpendicular increases, and as it becomes same as the hypotenuse, the base becomes 0 and the triangle collapses, isn't it?
Yeah.
So the triangle will collapse. So the maximum possible value for sine theta that you can obtain is 1. It is when theta becomes 90 degrees.
Yeah.
I just want to make you feel that what is going on. So
Yeah.
are you able to feel that what is going on rather than mugging it up?
Yes.
So it's all a interlinked play that is happening over there. All right. So what is the next important point that we came out with? The maximum possible value for sine theta is 1 when theta is 90 degrees.
Yes.
So I can very well say that I know the value of sine 90. Sine 90 degree
Yes.
will always be equal to 1.
Yeah.
Is it? Are you comfortable, Rajit?
Yes.
Anytime you feel as if I am going too fast or too above the level, just stop. Don't hesitate to stop me. All right.
Yeah.
Now, my second question, based on my previous question, you can very well answer it. Maximum value for cos theta, and for what theta we can obtain that.
Cos theta. So it's
Yeah.
P upon C space.
अभी बिल्कुल वैसे ही सोचना जैसे अभी सिखाया है, ठीक है?
Yeah.
And give me a theta value also.
So based upon hypotenuse here.
Yeah.
So the largest value we want.
Yeah. So I will go on expanding the base such that the perpendicular will collapse, isn't it?
Yeah.
So theta will tend to what?
So here, the triangle, you have to expand it till it collapses. So here,
Exactly. Exactly.
Yeah.
So perpendicular will tend to 0, right?
Yeah.
And this my triangle, this is the triangle, this is the theta angle, this is like collapsing, and perpendicular becomes same as hypotenuse. Base becomes same as hypotenuse, isn't it?
Yeah.
So the maximum value comes out to be 1.
1. 1. In every case, it will be 1 probably.
But theta is 0.
Yeah.
So cos is maximum when theta is 0 and sine is maximum when theta is 90.
Yeah, theta is 90.
All
sir,
right,
can
so,
I jot this down?
sorry?
Can I just note this one again?
I'll be giving you the notes, I think.
Oh, okay. So I'll note it down after class.
Even I have the recording also with me. So I'll be, if you will ask me, I'll upload the recording and will make you available for that. So don't worry, just be very free. Only keep this at the highest level at this point. All right. I'm making the notes for you. Don't worry. So the maximum possible value for cos theta is 1 when theta is 0 degrees. All right.
Yeah.
In both these cases, the triangle will collapse. So I am writing a hint over here how I explained it. Okay. Triangle will collapse. Okay, beta.
Yeah.
वेरी गुड. अच्छा, तो अभी तक हमारी क्या क्या लर्निंग हुई है एक बार उसको हम लोग सेग्रीगेट कर लेते हैं. ठीक है, एक तो हमने रेशोज के नाम सीखे हैं. ऑलराइट, वी हैव लर्न 3 रेशोज, sin theta,
Sine, cos, and tan.
one is this. Then we also learned that how to identify which one is perpendicular and which one is base. All right,
Yeah, so the one perpendicular to the angle, like just in straight of it. would
the
be-
one in front of the angle is the perpendicular one, right?
Yeah.
All right, all right. So, and these are the 4 learnings. That this is the 5th learning, this identity. All right, using the Pythagorean theorem. Pythagorean theorem is something that you already knew.
Yeah.
And this is the 6th learning, and this is the 7th learning. Is it correct?
Yeah.
Fine, perfectly all right. Okay, now let me just get you a question, a very small brief question,
Yes.
in order to get the concept right. All right, let's see. I have got a right triangle like this. Don't get puzzled up. Thoda sochna, you will get the answer. All right. So I've got a right triangle like this. So though it's a bit weird, but it's okay. This angle is 90 degree.
Yeah.
This is A, this is B, and this is C. And this angle I'm calling it as alpha. And I'm
Yeah.
calling this as beta.
Beta.
You know the notations?
Yeah. Kind of.
This is
Yeah.
this is called as alpha.
Alpha,
This is
beta,
called as beta, and this is
Gamma.
called as gamma.
gamma.
Is it all fine?
Yeah.
Now let me name the sides for you.
Yes.
This side be A, this side be B, and this side be C.
C.
All right. Now, my question. Very interesting triangle it is. All right. I
Yeah.
want these answers: sine alpha and cos beta. All right. Then I want cos alpha and sine beta. I want you to let me know that what these ratios will be by applying all the above concepts that I have told you.
Already, yes. So
Yeah.
in this case,
You can take time. No hurry.
yeah, in this case, the small a is the perpendicular.
Which case, when I'm talking about alpha thing?
Yeah, alpha.
Perfect.
And when you're talking about beta, then the small b or the large b is the perpendicular.
Yeah, fine. The B side becomes the perpendicular.
Yeah. So
Perfectly
in this
all right.
case, sine theta would be
Sine theta nahi, sine alpha bolo.
sorry, sine alpha.
Uh-huh.
I have to just like write like b upon c or something.
Yeah, that's all. The ratios thing. That's all.
So sine alpha equals
Uh-huh.
okay.
Mm-hmm. हाँ बेटा बोलो.
So here it is sine is
Sine alpha.
so sine is this, right? Perpendicular.
Perpendicular by hypotenuse. That's why
Hypotenuse.
I'm not showing you, so that you remember by the lecture, by
Yeah.
the end of the lecture. Yeah.
Yeah, perpendicular upon hypotenuse.
Perfectly all. Well.
Yeah. So it's a upon c.
Perfectly all right. This is your correct answer.
Hence I have to write cos
Alpha.
yeah, sir, 1 minute just.
Yeah, take your time, beta. No problem.
Cos theta. So
Cos
I mean
alpha.
cos alpha. Actually, theta is just embedded into my term, kind of like that.
all angles are thetas, right?
I don't know.
It's okay, no problem. Chal, bata mere ko.
Yeah. So,
Yeah.
now cos is this base upon hypotenuse.
Very
So,
good. Bolo.
which is the small b upon c.
Okay, बिल्कुल सही है. तो
So
sin
now
alpha
I have
cos
to
alpha
write,
तेरा बिल्कुल clear हो गया.
yeah,
बराबर है.
cos beta. So now I have to find that. So it is cos is again based upon hypotenuse. So
All
in
right.
this case, it would be a upon c.
Perfectly all right.
So
So
now
in case of
sine,
alpha, the perpendicular thing is A, right?
yeah,
And the base thing is B.
yeah,
While in case of beta, the perpendicular thing is B
yeah,
and the base thing is A. That is what you want to say.
yeah.
Perfectly all right.
Now in this case, sine